Assalamu alaikum and a very good morning to all of you. I am Amjad Ali here, Master in Chemistry and HOD Science Department in Pak Shama School and Doha, Qatar. Today we are going to discuss a very important topic of chemistry, acid and bases. I divide this lecture into two parts, and in part number 1 we will discuss introduction of acids and different concepts of acids and bases. First of all, I am going to share with you the introduction of the acids. The word acid is not an English word, it's a Greek language word, and they use this word for the sour substances. In their language, the sour substances they use word acidus, and later the same word is changed into acids. So acids were first recognized as a substance that taste was sour. Vinegar is very famous and it is available in your kitchens even. So it is sour because it is a dilute solution of acetic acid. So this acetic acid is a acid that is a natural and organic acid and it is available in our home. Citric acid is responsible for the sour taste of a lemon. So lemons are in our common use. Acids are classified into two, mineral acids and organic acids. Organic acids are weak acids and that acids even we can eat, like for example the acid present in lemon even, grapes even, oranges even, and vinegar. Vinegar the peoples they are using at home. Hydrochloric acid is a mineral acid, sulfuric acid, hydrochloric acid, nitric acid, these are mineral acid and these can be prepared in the laboratory. And lactic acid and acetic acid, formic acid, these are organic acid. As regard of introduction of the bases, bases are opposite to the acids. Generally, bases are called alkalis, are characterized by bitter taste. Acids they have sour taste and alkalis are bases they have bitter taste and slippery in touch. Example like in our homes, drain cleaner is there. We are using anti-acid tablets that are magnesium hydroxide or aluminum hydroxides or bases, baking powder, washing soda. All these are the examples of bases. Now we are going to discuss the different concepts of acid and bases. Number one is the simplest concept of acid and bases is Arrhenius concept. Arrhenius, he gave the definition of acid and bases. That is the simple one. Acids are those substances that ionize in water and give hydrogen ion. And bases are those substances that ionize in water, give OH negative ions. Here I show you the general example, simple example like Ha is an acid and it gives hydrogen ion in aqueous solution, so it is a Arrhenius acid. And base like BOH, it's a general example, it gives OH negative ion in aqueous solution, so it's a Arrhenius base. More examples, look at the more example, the famous and best example of the Arrhenius acid is a hydrochloric acid. If we dissolve it in the water, it gives you H3O positive and Cl negative. And NaOH is the famous example of Arrhenius base. So when it dissolves in the water, it gives OH negative ion. So it is an example of base. So look at there, even NaOH it gives Na positive and OH negative. HCl it gives H positive and Cl negative. There are some limitations of this concept. According to this concept, the substance must be dissolved in aqueous solution. So it does not explain, like for example CO2. CO2 is a acid or base, Arrhenius concept cannot explain. Why? Because there is no H or OH in CO2 and SO2, so it cannot be even explained. So why these are the acids even they don't, there is no H. And more famous is ammonia. Ammonia, its formula is NH3. From its formula, it is looking like it may be acid, but in real, it's a base. So Arrhenius concept cannot explain the ammonia even, the nature of ammonia. So another concept is required. So number two concept is Lowry and Bronsted concepts of acids and bases. According to the Lowry and Bronsted, the acid is a substance which donates the proton in an aqueous solution and base which accept the proton. So look at here the general example, like it is a acid Ha and B, and it is donating proton. Look at there, and the B base, it is accepting the proton. More you can see here. This one is a Lowry and Bronsted general acid like Ha. So after reacting with the BNE, so it gives this proton. And right now, this Bronsted acid change into the conjugate base. And this Bronsted base is changed into conjugate acid. More examples are here. Look at, right now, it's the example for Lowry and Bronsted acid. Look at sulfuric acid. If it allowed to dissolve in the water, it donates the proton to the water. And water H2O change into H3O positive, hydronium ion. And so it is a Lowry and Bronsted acid. The water, it is accepting the proton, so it is a Lowry and Bronsted base. More example. So look at more example. Famous the ammonia. The problem of ammonia is solved here. How? If it allowed to react with the hydrochloric acid, it accepts the proton from hydrochloric acid. Here, because it is accepting the proton, so it acts as Lowry and Bronsted base, and HCl donating the proton, so it acts as Lowry and Bronsted acid. Even this concept also has some limitation. Yani there are some drawbacks. For example, SO2, CO2, and calcium oxide and boron trifluoride. So look at this boron trifluoride. Boron trifluoride cannot accept the proton and cannot donate the proton. So there is no proton to donate. So it cannot be act as acid, but in real it is acid. So this concept is failed to explain the behavior of BF3 as an acid, and even other are also there. So look at SO2, CO2, calcium oxide, BF3 behaves as acid or bases, although they do not have the ability to donate or accept the proton. Nature of such substances cannot be explained by the Lowry and Bronsted concept, so another concept is required. Third and modern concept is Lewis concept. According to the Lewis concepts, acids are those substances which accept a pair of electrons, and bases are those substances which donate a pair of electrons. So this one is the general example. Look at for the more example here, the famous here ammonia, if it allowed to react with BF3. In BF3, the B, it belongs to third group of the periodic table. It has 3 electrons, and it already shared these 3 electrons here and form 3 covalent bonds. And right now, 2 to 4 and to 6. 6 electrons are there in its outermost shell. Still, it required 2 more electrons to complete its octet. So if it allowed to react with the ammonia, ammonia has a lone pair of electrons. So it can donate this lone pair to BF3 and combine with it and form a coordinate covalent bond between them. So in this way, look at here. According to this concept, ammonia is donating electron pair, so ammonia is a Lewis base. And this BF3, boron trifluoride, it is accepting the pair of electron, so it is a Lewis acid. So one another example is here. Look, water. Water, in the water, the oxygen has 2 lone pair of electrons. If it allowed to react with the hydrogen ion right now no electron, because in hydrogen atom there is only 1 electron, and H plus 1 mean right now no electron. So this water, it can donate this 1 electron pair to this hydrogen ion and form a coordinate covalent bond. So in this way here the water act as a Lewis base and this hydrogen ion act as a Lewis acid. So with this one, I am ending my lecture today. Inshallah, in our next lecture, we will discuss about the pH and pH scale. So please subscribe my channel, keep watching, and I'm ending with the message. Please take care of you and take care of the people around you. Okay, Allah Hafiz.